Hello everybody. In this video, we're going to talk about how to manage a scene that might be bigger in terms of resources or just in size than the plot you have. Or even if you don't have a small plot, you might have a larger one, you still want to think about conserving resources, not loading things that aren't needed up front. This will help improve your scene load time, as well as potentially improve the user's experience if they have a lower powered machine. In this GIF here, you can see how these paintings are rendered only when you get near it. This is an example of improving performance. All this code will be available in the Awesome repository under the lazy loading example. So here I have a lazy loading scene. This has been greatly extended to, instead of just having one scene, I now have 5 scenes. And if you look at the sub-scene setup, you can see how we can create these. We're making use of some new classes. There's a scene manager class and a sub-scene class. The idea is you can have multiple sub-scenes that are going to be managed by your scene manager, and you can then choose when to show or hide them. This is again extending on the concept of what you see here, because you can have sub-scenes inside of sub-scenes. So for example, in this video here, you see all of these paintings inside of here are in a sub-scene, which are then in a bigger scene, which is deemed like scene 1 in my example. So let's look at the live scene here. So here we have scene 1, where I might have some restrictions of space and I want to have a second gallery. You can vertically go up, or you could even have some mechanisms to swap your scene out. This might not apply to everybody, but if you wanted to make use of limited space, or even give the user more of an experience of like changing complete views within your scene, you're going to want to potentially make use of this, and you don't want to be rendering something that the user's not going to see. So when they change to scene 2, there's no point in rendering and wasting all the resources. And that you can see by pressing Y in this debug panel here. I have this scene modified from what's committed to show you like the worst case scenario. In this case, all of my scenes are loaded up front, and while still hidden, which does have a performance benefit, I'm still eating up a bunch of these counts. Like I'm using up materials and meshes and bodies. And if they're lazy loaded, that's great, but notice these counts will go up and they won't go down. Let's go to near one that hasn't been loaded yet. So there, I just jumped to 59 and 51 textures. If I come over here, I want to 65 and 61 texture counts. That's the lazy loading. So while lazy loading has an advantage here, we're not garbage collecting it as best we can, and there's pros and cons to that. You have 2 choices for how you're going to want to manage your resources. Hiding them from being visible does have a performance boost. However, the engine is still aware of it, but the CPU or GPU won't be spending time rendering that thing, so it does have a performance gain. But you still might want to take this further and remove it from the engine. Removing it from the engine prevents it from being rendered, visible, or otherwise. The engine doesn't know about it. However, there is some upfront loading cost time, so you need to kind of balance what you do when. So the scene you see here, as I toggle between them, so this is scene 2 or 3. Here's scene 4. This is taken from the Awesome repository as well. This is the museum template. I have the trigger visible, which actually I think I can talk about now. So right now, the strategy that I'm using for hiding and swapping scenes is purely making them invisible. Now, an added thing that I'm doing, which might not be needed in the later versions of the SDK, is I have what is called like a position vault. So when things are hidden, I make the GLBs hidden false, or visible false. However, and you can see these strategies are defined here. You either have add remove from engine or show shape show hide. What I mean by engine add remove or show hide, if I dive into the hide method far enough, we will find here. So at the end of the day, way down inside of entity wrapper, we have, if the strategy is shape show hide, it will grab the engine's shape, which could be box shape, cone shape, anything to implement shape, and it'll turn the visibility on or off and turn off colliders. And then it'll take that vault location and replace it with the current transform, basically making the scale 0 so you can't see it and moving it out of the way somewhere. That's defined here. And the other one is the engine add remove. And engine add remove is pretty simple again. It's engine.remove entity or it's engine add entity. And in my constants class, which you could play with this, right now I have the worst not the worst, but a less performant flagging of where I would add everything to the engine on scene load and I'm shape show hiding. And by that I mean, so this trigger, by the way, I have a location of where you can choose to put these things. It's defined inside of this subscene here. You can change it to your scene's dimensions, try to put it where the player won't be. The scale is 0, so it won't be visible anyway, but still I put it up high and out of the way. So when I make this scene hidden, it gets moved up there into the vault, and triggers won't be visible anyway, and the trigger doesn't know to scale down. Also, an interesting use case is how I mentioned sometimes you might want to stack your scene. So in scene 4, I have a platform floating above, which I can then jump back up to if I wanted to. But the interesting thing is I can change scenes and move up to it. Another one is talking about what do you do with systems? Systems you need to be careful about. So in systems, if they're not tuned right, will affect everything in the scene. So you need to load and unload your systems when that scene or subscene is active. Otherwise, everybody's going to be rotating, not just this cube. And then lastly, if I go to my empty scene, because we have these settings of unload everything at once, just show hide, which does have a performance gain, but you could get more maybe if you use the engine's add remove engine. I have nothing loaded except for this, and notice my model counts are very high. So the first thing we're going to do is I'm going to flip these two flags to lazy load. Don't add it to the engine on scene load, which is going to have some performance gain. So now looking at this, my material counts are pretty low. My texture counts are low. Things only get added when they get rendered. And to take a quick look at how that works is in one of my scenes here, right now they're being loaded on scene render, but what I could do is I could wrap them inside of this on init listener. So when this subscene gets initialized for the first time, either explicitly or on the first time it gets called to be shown, then it'll load this stuff into the engine. That has some additional benefits of keeping the initial scene load light, as well as not putting anything into the engine until it actually is needed. What if the player doesn't come to scene 3? Why spend effort in CPU loading that? And so now my entity count is down to 73. I think I can do it in one more scene here. Okay, so now as we switch around, notice we're not removing things from the scene, so we'll still have that growth of entity counts and material counts as we swap through them. However, we're deferring. Notice the entity count jumped here because a lot of things are being loaded by this engine. We don't pay the cost of loading them into the engine or scene load until this oninitialize gets called, which is a nice feature of this class. But we still have these counts are going up and up and up. You have to tune it to your scene's needs. It is worth noting that once loaded, if I was to toggle through this thing twice, it would load much faster the second time because now these things have been made aware to the engine. So there's pros and cons to adding and not adding things. Before I switch the next thing, the visibility thing, I want to talk about this change scene functionality. So in scene setup back here, you can see that each scene is being created inside of its own file. This is just conventional, so a lot cleaner for your code base. And what we're going to use is we're going to use the scene manager called change to scene, and we're going to pass it the scene itself or the scene ID, which you could look up or store somewhere, however you want to operate that. But the change to scene, if we look in here, it's going to loop through all its known scenes and hide them. And then at the end, enable the scene you're trying to load. So that lets you swap it, but it leaves the player in place. Well, what if you wanted multiple levels? This is where you can, in my scene 5, which is off the ground, scene 4 is off the ground, I have a platform floating in the air. What you can do is define spawn points. So in here, when I'm defining my platform 4, I define spawn points, and you can have more than one in here, and it's using the idea from the scene.json where you can provide a range so that it tries to randomize user placement, just like if you were going to load into the scene initially. And when you make a call to change to scene, you can also say move the player here, and it'll randomly pick one of those spawn points and move the player. In my case, I only have the one spawn point, so it's always going to move the player right here. But I could put a few and it'll randomly pick them around. There's other things when you dive into here. You can also provide a filter, and you can register different types of spawn points. So I could register a type of like an enter type, and then I could also define a exit type. So let's say you wanted to move the player around within a scene, not just when you're swapping. You could then say, all right, I'm going to have move to ground, which is going to send me to 8,8, 1,1, 16,16 should be kind of center-ish. And then you can pass in a target of where to move that player to. So if I come in here, my move player could actually say, hey, I want to move the position to the exit position only. And I'm going to target that one. So now what should happen is it moved me. Bad choice of spawning positions. I spawned directly on top of that, but notice it didn't send me up there because it's selected from the... You can have more than one spawn point again with the same type. So I can have an exit point there, and a few, and it'll pick which one to send me to. So I want to go enter, and now still sitting on that. Now it sent me to the enter spawn point. So you can make use of those how you choose, but that's also nice to encapsulate spawn points within a subscene. Okay, so now that we talked about that, we're going to now change the scene's optimization. We're going to make one more optimization. We're going to say only do when it's not visible, remove it from the engine. Again, there are pros and cons to this. You can set it per scene. All my scenes right now are using the this constant that I have. If I look for references, you can see that every single one of them is defining itself visibility by that constant. But you could say, all right, for scene 2, show hide, it's not heavy, but for scene 3, add remove from engine. And you can take it even further. You can take it down to the entity level. So this might be a good time to show you a class diagram. All right, so in this class diagram, you see we have the scene manager, and its job is to be aware of all of the sub-scenes and manage and looping through and allow you to change to them and show and hide them. In each sub-scene, you add scene entities, which is a wrapper for the entity object itself. Both the sub-scene and the entity wrapper extend this base entity wrapper thing, which has the visibility strategy as well as the on hide, on show, listeners and register listener methods. This is pretty powerful because you can have scenes, subscenes inside of subscenes, and since they both extend this, you could not only listen to on show on hide from a subscene perspective, the scene entities, which you do is you do subscene.add entity, which then wraps it in a scene entity. You can also define the visibility strategy of that sub-entity, or you could even register hide, show, init listeners. So you can take this really far, where you could have the scene level visibility strategy at add, remove engine, and sub-entities doing various things like that. Also within the scene here, you can see we have a subscene inside of this gallery 4. We have these 3 paintings are a subscene of gallery 4. And using the visibility strategy, you could choose to say, gallery 4, your unload engine add remove. Gallery 5, your hide show. And take this on and on and on. Or you can choose that the gallery buildings are show hide, but the paintings are engine add remove. It's whatever you need for your scene. All right, finally, we're going to switch it and show you what I mean. So now I'm going to say engine add remove. So the 2 flags that I've changed is I have added to engine on scene load false. That should make my page weight pretty light. I'm not loading all 5 scenes. And then only adding to the engine when it's visible, and then removing it from the engine when it's not visible should also keep this very light. And you can see this immediately with these textures in here. So if I walk away from gallery 4, as long as I didn't spawn gallery 1, try to stay in the middle too. All right, my entities are 70, texture count 6, materials 5. When I walk up, these numbers jumped. When I step away, these numbers drop back down. So this is the most extreme version of conserving resources for scene management, is removing them from the engine, not just making them invisible. Again, there's pros and cons. So as I jump through these scenes, notice the entity count should only be relative to what's visible and in the engine, which is the only thing that's in the scene because of those entity settings. Notice this one jumped pretty high. I'm on top of this platform. Let's go to the empty scene. So when I go to the empty scene, I can kind of prove this is working, because notice my entity count drops. My texture count should drop drastically. If these numbers are high, like these look a little high still, maybe I missed marking something correctly, because nothing should be rendered right now. It should be the lightest thing possible. 49 is really low. When I started this scene just fresh, I started at entities 73. So I must have more entities than I realized in the scene. But that's kind of give you the baseline of like what an empty scene's weight should be. One last thing I wanted to address is systems. If a system, in my example here, a system is going to be defined by transform and rotator system components. So anything that has this will be operated on, and that could be good or bad. So you need to be aware of that with how you go about this. If you remove and add items from the engine, it's less of a concern than not. So again, it depends on your use case, but here's an example of where I'm going to add the rotator component system. Everything already has transforms. 2x-1. Let's say I wanted to reuse that system in 2 spots. And again, there's more than one way around this, but I just want to prove this to you. So first, the system doesn't get loaded in the scene until where are we here? So we have this on show on hide, where we can make use of the listeners to say, okay, only have the rotating system active when my scene is visible. So that's one good thing. So it hasn't affected my scene yet. But once I load that cube and it's rotating, if I come back to scene 1, everybody got rotated. So that's an example of where if it's just marked invisible, it's still visible to the engine and will be operated on. And there's again things you can do, like you could either mass add, you could even make this system object more global and try to manually manage its members. You could add in additional components when hidden that you could then say, okay, and then you have to make all of your systems aware of this. When it's hidden, it has this extra component called hidden and don't operate on it. Or you could make use of when it's not in the engine, it's not operated on, which is the quickest and dirtiest solution, but maybe you need to go with that hidden component option later on. So let me look at my globals here. If I do the engine add remove and get to my rotating cube, so there's my cube rotating. When I switch this one, nobody got modified because they weren't in the engine for that system to see it. And the fact that I removed the engine once it got loaded, which you saw me doing here, was also important, because if I did not remove the engine when it got hidden, the engine would, the system would still be operating and would start affecting them as well. So here, the system is not operating on them once they become available to the engine. So making use of these on show, on hide, very helpful for curtailing what you want to do on these events, and then making use of subscene here will, the scene manager just kind of like makes it a lot easier. You just say change scene 2, and you don't have to, it handles a lot of that pain for you. One last thing that I think is worth talking about is when you add and remove things to the engine, or even when your scene's loading, there is a delay time. And if you're sending players in the air, like up here, I can exaggerate this for you. I would strongly recommend that you spawn an invisible pad, which I'm going to make visible right now. And I'll explain why. So and I have one currently. Where's mine? Here it is. So I have an invisible platform that also is part of the parent-child relationship, so it's only visible when I jump to that scene. But on first load, it was probably hard to see. This platform's not there, and its collider is not there. So if it doesn't load in time and I send them up there, they're going to fall through the floor. And I can exaggerate that with a timeout. So this is kind of a game of Inception here. I have a sub-scene on init listener with an additional timer of 3 seconds, then add my platform to the scene. So it'll only happen on init. If I wanted to, I can move this to an odd show hide, which might be interesting to then exaggerate that a little further. But for now, we'll leave it like that. So, okay. Showing you why you want invisible platforms to give a player somewhere to land is just like this. So I'm going to click this to go to the one in the sky. I landed on a cube because it's not a model, and then finally my entity loaded in. It's hard to think about because locally things load fast, but you'll start seeing it when you deploy to world because it's downloading these models and rendering them as it gets them. So that is a really good practice. And if you really wanted to, not that cubes are heavy, after loading, I could have a thing that says, okay, this thing finally loaded into memory, remove this. However, again, when you add remove into the engine, there's that glitch. You probably just want to leave this here always. You could do this conditionally. Like, there's lots of things you can do, and you can take this pretty far. So that's scene, multi-scene management and resource conservation, how to make use of this debug panel to kind of check your progress. If you remember when we first started, so if I go to the empty scene now, it might be hard to read, but my texture count is 13, materials 45, entity count 49, which isn't bad when I consider if I put these two back to false and shape show hide, my initial scene, set that to true. My initial scene weight before doing anything. Oh, and this is still lower because also don't forget I added these only initialize objects inside of a scene listener. But either way, it was 40. Entity count was 45. It's 87. This just is an example of how to measure and how you could maybe make use of this little framework that I provide here for how to optimize your scene. and switching between them. For example, again, you might have several galleries or something in the sky you want to spawn them to. Just some good ideas of how you could go about that and still conserve resources so that all players of all different machine powers have a good experience. Thank you again, and happy building.